All right, I'm going to go over homework 29, which is one of your reviews for the test 2. You should also do the warm-up that we have on Wednesday and the extra credit assignment. Between the 3 assignments, that is comprehensive of what's possibly on the test tomorrow. So we'll start with describe a function as either growth, decay, or neither. The first thing we should look for is if it's neither, then the a is less than 0. So if I have a negative in front, that is neither. Growth has a b greater than 1, and decay has the b between 0 and 1. And it's in the form a times b to the x power. So for number 1, a is positive and b is greater than 1. 4 is greater than 1, so this is growth. Now number 2. 2 is greater than 1 or greater than 0, so it's either growth or decay. 0.46 is between 0 and 1, so this is decay. Number 3. Positive 1 in front there, so this is either growth or decay. 6/5 is greater than 1, so this is growth. Number 4, my a is negative, so that means it's neither. Number 5, y equals 2/7 to the x. 2/7 is between 0 and 1, so this is decay. Now be on the lookout for problems that have a negative in the exponent, because that negative in the exponent switches it. So if I had y equals 2/7 to the negative x, that would be growth, because it flips it to 7/2 to the x when I apply that negative. So be on the lookout for that. Same thing is true with e functions. If I have, say, e to the negative 3.5x, this is decay with an e with a negative exponent. And if e is a positive exponent, 2.1x, then this is growth. E is always greater than 1, greater than 1. So you have to look at whether the exponent is positive or negative when it's an e function. Number 6, we write as a log. So remember that the base is what's going to change. The base is the 4, so it's going to come over here. Log base 4 of 8 equals x. The variable or the exponent and what's on the other side of the equation stay on the same side. That moves over, becomes a log, the base of the log. Same thing for number 2, or number 7. 2 is the base. It's going to move over here and become a log. So n plus 8 stays equals log base 2 of 16. I'm not asked to solve these, I just want to rewrite them. 1/2 is my base, so 1/2 goes over. 3x, my exponent comes down. Log, the base of the exponent becomes the base of the log, so log base 1/2 of 81. The 10 is my base, so this moves over. Log base 10, we don't write the base for, so it just becomes the log of 3 equals n minus 5. Again, notice that what's on this side of the equal sign is staying on this side of the equal sign. Right? The 3 stays, it goes into the log. The exponent stays on the same side. Right? The only thing that's switching is the log. It's either becoming the base of a log, or in the next set of examples, it's going to become the base of the exponent, or the power. We have 1.5 equals e to the n minus 5. The e is my base. That becomes the natural log. So ln of 1.5 equals n minus 5. You can always use the flashcards to practice those. Rewrite in exponential form. Now we're going the other way. The base of the log becomes the base of a power. So x plus 5 stays on this side. 3 to the 8th. The base of my log is a 7, so this becomes 7 to the power of 12 equals 3n. No log written, that's log base 10. So it's going to come over there, push that up into the exponent. 10 to the 4th equals x minus 7. ln, remember that's a capital, that's an L, not an I. Log base e. E comes over, and over 5 stays, e to the 8th. 8 becomes my power, or my exponent of my power. Now we're going to use a calculator to evaluate these expressions. It's very important when we are evaluating expressions with the calculator, we recognize what's inside the log and what's not. For number 15, it's the log base, or the log base 10 of 7, and then we're going to add 3. If this was 7 plus 3, then the 3 would be inside the parentheses, but it's not here, so we're going to make sure we close the parentheses on our log. Okay, so here's our calculator. Let's see. I'm going to do the log of 7. We're going to close the parentheses and then plus 3. So that's 3.85. It says nearest hundredths. The next one is the natural log. That's the ln button of 13 divided by 4. So we can do 13 divided by 4 in the parentheses. Close the parentheses at the end there. 1.18. 17, e to the 4th. E is the inverse of ln. So you'll notice it's the second key there. There it is. So I'm going to do second ln. I get e to the power. This calculator opens the exponent to the 4th. You can close it if you want. 54.60, because it says to round to the hundredths. And then lastly, number 18, 7 times. In this calculator, you don't have to hit times, but if you're using a cell phone calculator, which you don't get to use on the test, you don't have to, or you have to put the times, otherwise it puts the 7 into the natural log. So 7 times the natural log of 8, close your parentheses, we get 14.56. Let's see, stop. Okay, write the inverse function for each equation. We have pretty much 4 steps. The first one, change f of x to y, if it is. 2 is swap x and y. 3, rewrite the logs as exponents and the exponents as logs. And then lastly, you have to get y by itself. So for number 19, 1 is already done. So I'm going to do step 2, swap x and y. X equals 6 to the y plus 7. Now the y plus 7 is in the exponent, so I can't mess with that. I have to rewrite it as the exponent as a log. So the 6 is my base. So it becomes log base 6. And everything else stays on the same sides of the equal sign. X equals y plus 7. Now that that y plus 7 is out of the exponent, we can subtract 7. And I'm not subtracting inside the log, so log 6 of x minus 7 equals y. All right, really what's inside the log is just the x. And you could put parentheses around that x by itself if you'd like. Number 20, change the f of x to y, 4 to the x plus 9. Swap your x and y. X equals 4 to the y plus 9. Now we're going to, 9 is not inside. It's not in the exponent, so I'm going to move it first. Okay, that line is not because I'm dividing. Minus the 9 because it's not up in the exponent. So we have x minus 9 equals 4 to the y. Now I can rewrite my log, but I'm taking the log of the entire left side, so this is going to end up in parentheses inside my log. The base of my log is 4, so log base 4 of x minus 9. The parentheses are absolutely necessary here because the x minus 9 is inside the log. Number 21. Again, there's no parentheses around that x, so the x is really the only thing inside the log. So we're going to start by swapping it. X equals log 3 of y plus 5. We can move the 5 to the other side because it's not in parentheses, it's not inside that log. X minus 5 equals log 3 of y. Now that base of my log becomes the base of the power. So 3, and then x minus 5 becomes the exponent to the x minus 5 equals y. And y is by itself, so I don't have to do anything extra. Now here's the difference. Now my x minus 3 is inside parentheses, therefore the minus 3 is in the log, and I can't do anything with that. I have to worry about it after I get the log on the other side, or the log into an exponent. So we're going to rewrite the x equals log 8 y minus 3. The 8 is the base of my log, so it becomes the base of my power. 8 to the x power equals y minus 3. I don't need parentheses anymore because there's nothing on that side. We can add 3, and we can't add it to the power. It's just x to the 8th plus 3 equals y. Now we'll get into some a little bit more complicated ones with e. So I have to swap it. X equals 3 times e to the y plus 1. And now I have to get the e to the y by itself. So we're going to subtract the 1. X minus 1 equals 3e to the y. And then we're going to divide by the 3. X minus 1 over 3 equals e to the y. Now I can rewrite it. The base of my exponent is e, and that becomes the natural log. And what's inside the natural log is the x minus 1 over 3. That equals the y. So what's on the left side goes into the log, and the exponent becomes what it equals. Number 24. X is equal to 1/3 log of 2y minus 5. So again, I can't rewrite it as an exponent until the log part is by itself, so we're going to add 5. I'm going to get x plus 5 equals 1/3 log of 2y. To get rid of the 1/3, we're going to multiply by 3. So I get 3x plus 15 equals the log of 2y. Now this is log base 10. When there's no number written, it's always a base 10. So 10 is going to become the base of my power to the exponent 3x plus 15 equals 2y. And now we can divide by 2. I can't divide the base of the power because exponent has to come before division. So the best I can do is write this as 1/2 times 10 to the 3x plus 15. I wrote that wrong. There should be a 1 in front of that there. Equals y. Okay, so you cannot divide the base by that 2 because you have to do an exponent first. You can't do the exponent when it has a variable in it. Same is true about multiplying the number in front. I can't multiply the 1/2 times the 10 because exponent comes before multiplication. And I can't do that exponent when it's a variable. All right, let's graph a couple exponential growth functions, growth or decay. The first one is growth. This one is decay. So when I'm graphing, I start with -2, -1, 0, 1, and 2 in my table. I get 2 to the 0 power is 1. 2 to the 1 power is 2. 2 squared is 4. 2 to the negative 1 is 1/2. And 2 to the negative 2 is 1/4. Remember, this one has an asymptote of y equals 0. That's the equation of the asymptote. Y equals 0. And then I can plot these points. Let's zoom in a little bit. Negative 1, 1/2, negative 2, 1/4, 0, 1, 1, 2, and 2, 4. This is a curve that's going to get really close to my asymptote, but not actually touch. Now my domain on this function is x is greater than, x is contained in the set of all real numbers. My range is that y is greater than 0. It's not equal to, it will never actually touch it. So it's just y is greater than 0. And we're going to plug in the same numbers for 1/2 to the x. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. 1/2 to the 2 is 1/4. 1/2 to the negative 1 is 2. 1/2 to the negative 2 is 4. So you should notice that this graph is a reflection on the y-axis. Equation of the asymptote is y equals 0. And I have my points. Right, negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, 2, 1/4. Domain and range are the same. Domain all real numbers. Range y greater than 0. Okay, so when you're asked to graph these, just plug in negative 2 through positive 2. Draw your asymptote at y equals 0. Make sure you identify that equation, y equals 0. There's going to be a part of the question that says, what is the equation of the asymptote? Y equals 0. And don't forget to draw your asymptote on the graph, and then draw your curve close to it, but not touching it. All right, now we're at the word problems. Zombie apocalypse hit EHS again, and there were initially 5 students infected, and they infect at a rate of 3 people per day. Create a table for the first 4 days. What's the growth factor? Write the model that provides the number of infected on any given day, and what is the rate of increase? Okay, so let's write out our initials. A is 5. My rate of growth rate is 3. So when I look in my table for 4 days, day 0 is 5. Each of these 5 people infect 3 more. So let's draw just one person infects 3. So for the initial person, there are 4 infected now. So that means my growth factor is 1 plus 3, which is 4. So I'm going to multiply by 4. In day 1, it's 20. In day 2, there's 80. In day 3, there's 320. And day 4, I need a calculator for that, 1,280. So my growth factor is 1 plus r, the rate at which, there it says, at a rate of 3 per day. So 1 plus 3, the growth factor is 4. The rate of increase is 3. And then the equation, y equals a, 1 plus r to the t. So y equals 5 times 1 plus 3 to the t, which is 5 times 4 to the t. Okay, so remember that this part is the factor and the 3 is the rate. What is the balance after 5 years? So t is 5. When 2,400 is deposited, that's the principal, 2,400, into an auth-IRA that's compounded continuously at a rate of 0.042. Compounded continuous formula is A equals PE to the RT. So that's 22,400 E to the 0.042 times 5. Now, in my calculator, I'm going to plug it